What happens when you add two vectors that are equal in magnitude but opposite in direction? It results in a vector possessing zero magnitude and is called a null vector or a zero vector. In case of a null vector, you cannot specify direction. Various operations with a null vector are: a plus 0 is equal to a, lambda 0 is equal to 0, and 0a is equal to 0. Let's discuss the physical meaning of a null vector. Consider a body is occupying position P with its position vector r at time t. From time t to t dash, it moves from position P to P dash. Its position vector at time t dash is r dash. From time t dash to t double dash, it moves back from position P dash to P. The displacement of the body during the time interval t to t double dash is 0, as the body has returned to its initial position. Its displacement is thus represented by a null vector, which is just a point with zero magnitude and without any arrow. Now let us discuss the parallelogram method for the addition of vectors. Consider vectors A and B which are to be added. Redraw the two vectors with their tails coinciding at a common origin O. Complete the parallelogram by drawing parallel lines. Then, draw a diagonal passing through O. At the end of this diagonal, display an arrowhead. The diagonal represents the resultant vector r. After addition, you will now learn about the subtraction of vectors. Direct subtraction of vectors is a little confusing. To avoid this confusion, you must use the concept of addition of vectors after reversing the direction of the second vector. Vector minus b is added to vector a to get r. This method makes the subtraction of vectors easy. Earlier, you learnt about the addition of vectors by the graphical method. The accuracy of the results obtained using the graphical method depends on the scale you chose and your ability to draw exact parallel lines. You can get accurate results using the analytical method of vector algebra. Before learning the analytical method of vector algebra, you should understand the concept of resolution of a given vector in any two required directions. To understand the resolution of vectors, consider three vectors A, B, and C lying in one plane. In this case, you need to resolve vector A along the directions of B and C. O and P are the tail and head of A respectively. From O, draw a line parallel to B, and from P, draw a line parallel to C. Let these two parallel lines intersect at Q. On the line OQ, display an arrowhead at Q. Similarly, on the line QP, display an arrowhead at P. In this case, the length of the line OQ is 2.5 times the length of B, and the length of the line QP is 3.2 times C. Hence, from the triangle OPQ, you can write A is equal to 2.5 times B plus 3.2 times C. 2.5B and 3.2C are known as the components or resolved parts of A along the directions of B and C. In this expression, B and C are the unit vectors, and 2.5 and 3.2 are real numbers. Usually, vectors are resolved along the axis of a rectangular coordinate system using unit vectors for convenience. Unit vectors have a magnitude equal to unity, and they indicate a particular direction. You do not specify any dimension or unit for these vectors. They only indicate direction. Unit vectors along the direction of the x, y, and z axis of the rectangular coordinate system are denoted by I cap, j cap, and k cap respectively. These three unit vectors are perpendicular to each other, as the three rectangular coordinate axes are perpendicular to each other.